Another explorer has joined the search for new knowledge. Another man-made satellite has been hurled aloft by the United States to join other satellites in outer space. The successful development of the Jupiter missile by the United States Army provided the basic unit essential to carry out this tremendous task. The D002 rocket was employed to launch the Explorer satellite. It is a modified Jupiter plus high-speed upper stages. Months ago, the Army Ordnance Missile Command was given the opportunity to contribute to the national program for the exploration of space. The National Aeronautics and Space Administration called for studies concerning the kind of scientific experiments and the total weight that could be orbited over the Earth by the powerful D002 rocket. Now, the D002 would add a new chapter in the continuing effort to learn more about the space beyond our atmosphere. Top scientists of NASA, the Army, and research institutions studied the problem to determine how best they could employ the giant rocket's power. They had to decide what would be the best altitude for the artificial moon, how much velocity would be required to place it in orbit, which tracking stations could follow its journey. Thousands of decisions and no room for error. It was agreed the satellite's maximum weight would be 91.5 pounds. This would accommodate 7 experiments to yield data about cosmic radiation activity, as well as other measurements to increase our understanding of outer space. The path of the satellite was planned to pass over the Earth tracking stations. Work began at once to design and fabricate the satellite. Miniaturized components were fitted into the precise spaces that had been designed for them. The instrumentation presented a unique challenge because the equipment had to function flawlessly once Explorer was in orbit. You can't drive to a service station for repairs in outer space. The satellite was designed, fabricated, assembled, and tested by experts of the Army Ballistic Missile Agency, selected to conduct the task by NASA. 5 of the experiments were provided by universities and research laboratories. Dr. James Van Allen of the State University of Iowa provided the cosmic ray experiment. Dr. Herbert Friedman of the Naval Research Laboratory provided an alpha X-ray experiment. Dr. Vern Suomi of the University of Wisconsin furnished a radiation balance experiment. The Research Institute for Advanced Studies provided another cosmic ray measuring device. Dr. Herman Legau of NASA provided a device to measure meteorite impacts. The Army Signal Corps included a solar cell experiment, an unprotected silicon cell on the outer skin of the satellite to determine its possible use in future space projects. The Ballistic Missile Agency installed instruments to measure temperatures. The cosmic ray detector package was placed atop the satellite designed by Joseph Böhm of ABMA. When the instrumentation was at hand and in the satellite, rigorous tests began. The satellite was placed in a sealed container. The air was pumped out to create a vacuum, and performance of the instruments was checked at extremes of temperature comparable to those of outer space. The testing subjected the satellite to wobbling motions it might encounter in its journey. Next, it survived a centrifugal or high-speed spin test. The power units within Explorers include solar cells drawing energy directly from the sun. These too were tested. The cells are the small window-like squares on upper and lower plates. The tests indicated the solar cells would perform their mission. Then came bounce tests to assure that the sensitive instruments would withstand the terrific forces of launching. As the giant D002 lifted off the launching pad, it would quickly gain speed and roar into space at thousands of miles per hour. When Explorer was pronounced ready for firing by the Army team, the satellite was carefully packed for shipment. Then it was loaded inside a plane for its flight to the Atlantic Missile Range, final stop on Earth before the pre-scheduled firing date. Meanwhile, as work progressed on the satellite, assembly of the D002 rocket began in the laboratories of the Army Ballistic Missile Agency. Thousands of miles away in California, the Jet Propulsion Laboratory of NASA prepared the high-speed assembly which would be installed on the modified Jupiter main stage rocket. The Jupiter booster, clamped securely to the huge static test tower at Redstone Arsenal, underwent a full firing test. The smooth roar of the liquid-fueled rocket engine satisfied the engineers responsible for its performance. Generating 150,000 pounds thrust, it would carry the satellite vehicle on the first leg of its journey. Static tests completed, the D002 went back to its builders for final checks. Then it was ready for shipment to Florida, where its passenger waited. Weighing 6 tons empty, the big rocket would weigh 60 tons when fully fueled at the instant of launching. This would be its first satellite mission. 2 earlier D002s had carried the Army NASA Pioneer space probes. At Cape Canaveral, Florida, the Army's missile firing experts unloaded the D002 and trucked it to the hangar for its last checkout on Earth. Every part was once again scrutinized. The inertial guidance and control system was checked to ensure it would function perfectly. A short trip over the Cape's road network ended at the firing site. There, D002 was placed upright on the launcher ring. Platforms of the tall service tower embraced it and provided access to the servicing crews. The rocket was aligned in the direction of its planned trajectory. "30 minutes before firing, the tower would be rolled back and D002 would stand alone, waiting the firing command. A metallic shroud had been designed by Army technicians to protect the upper stage rockets and satellite. Explorer was now positioned atop the giant D002 carrier rocket. A protective covering completed the assembly. During passage upward through the atmosphere, the rocket would be subjected to terrific heat. Now, the satellite's time on Earth was growing short. The almost human electronic computers at Redstone Arsenal had computed the rocket's course to determine the exact point in space where Explorer would begin its unpowered journey in orbit. Ton after ton of kerosene and liquid oxygen poured into the rocket's tanks. Mixed at the instant of ignition, these chemicals would supply the thrust to lift the heavy vehicle off Earth's surface and carry the roaring monster through the atmosphere. It would follow a course roughly parallel to the eastern coast of the United States as it soared northward into space. Inside the blockhouse, the Army team proceeded with the methodical countdown.
9, 8, 7, 6, 5, 4, 3, 2, 1. Fire command. Fire command.
Juno 2 flamed into life. It accelerated rapidly as the thrust force overcame Earth's gravity. Instantly, the tracking station zeroed in on signals coming back from the rocket and traced its course as it roared away. At stations along the East Coast, on islands far down the Atlantic missile range, radar and radio ears heard the voice of Explorer as it rushed to meet its destiny. As soon as the main stage exhausted its fuel supply, it was separated from the upper stage assembly and fell away. Automatic controls tilted the upper stages and satellite into the correct position, roughly horizontal to the Earth's surface. Coiled springs pushed the shroud cone ahead of the upper stages. A small rocket kicked the cone out of the way. The 11 solid fuel rockets of the second stage ignited, boosting the velocity of the satellite. Seconds later, 3 more rockets. The third stage flamed into life, increasing the speed. Then the single rocket of the fourth stage boosted the velocity to about 18,000 miles per hour. Explorer separated from the final rocket, and both continued along the trajectory. Radio antennas mounted on the satellite reached out to their full length of 24 feet, and Earth tracking stations tuned into the signals. Moon watchers manning tracking stations were on the alert for the voice of the new Explorer. Soon the National Aeronautics and Space Administration announced the satellite was in orbit. Man had taken another step away from Earth, pushing back the horizons of knowledge, striding boldly now toward the conquest of the last frontier, space.